Hello, everyone, and welcome to Pisa Presents, or rather, welcome to Earth. For today, we're going to be taking a wonderful trip down into the Grand Canyon, specifically into its geology. Now, we're going to be treating the canyon like, well, rather like a book, because anything as complex as this, think of each and every individual rock layer, and there's about 40 of them as a chapter in a rather large book. Now, obviously, with a book, you can do a little bit of finagling around and kind of figuring out your way if you read things out of order, but still, you're going to miss a lot of things. So, what we're going to do is we're going to start at the beginning of our book, that is this canyon, and we're going to start at the beginning reading these rock layers in turn and then going on up to the top, and then also too looking into a little bit of the various erosional instances along the way too, and then a very brief instance at the end, and to when we look into just how this absolute marvel became a national park. So let us begin. First of all, we're going to look into some of the work of this wonderful guy named Nicholas Steno. So you're going to see him mentioned a lot in various works about not only the Grand Canyon, but just really anything that mentions the science of stratigraphy in general. So he came up with a lot of different laws and principles. So law of superposition, original horizontality, lateral continuity, and cross-cutting relationships. You're going to see these different laws and principles mentioned a lot in geology when it comes to determining the ages of various rock layers. So Steno was the guy that came up with these, just to kind of throw out his name and what he looks like, to kind of put your name into his mind, to look into him, because it's very interesting, sort of some of the stuff that he came up with. So just to very quickly go into some of the key ones here. So, law of superposition, younger rock layers are always deposited atop older ones. Principle of original horizontality, rock layers are originally deposited flat. And the principle of cross-cutting relationships, if B is a layer of rock cross-cutting layer A, then B is younger than A. Now, and those are very formative when it comes to dating not only things like the Grand Canyon, but just really other large, really just other geologic formations in general, or just really anything geologic. Now, I wasn't really quite sure how to react to this quote, but I just thought it was absolutely priceless, so I wanted to put it up. So, this is from the Grand Canyon Trust website, and they said, and I quote, "You'll notice a couple things immediately when you look across the Grand Canyon. First, it's a really big ditch." Indeed, it is. Now, just how big of a ditch is that, my friends? Well, nearly 40 identified rock layers, 277 miles long, and 1,217,262 acres as a national park. That is indeed a very big ditch. Now, this is a look into the ditch itself, aka the Grand Canyon, with a very, very tiny just cross section, a little taste, if you will, an appetizer, into a bit looking at some of the older rock layers. Now, what is really the oldest established group of rocks within the Grand Canyon? If you know, it's actually pictured right here. It's in the crosshatch layer. It is the Vishnu basement rocks. So now let's start with those. So the first chapter in our book, if you will. Here is a close-up of some of them right there. Now, the Vishnu basement rocks, or also called the Vishnu group, they were named for the Vishnu temple feature on the left, which were, of course, then in turn named for the deity Vishnu. Now they're both felsic and mafic, which are geology terms referencing the iron content of something, with later igneous intrusions. Now they're roughly 1.74 to 1.75 billion years old, and they have an adjoining Pluton, which is called the Elves Chasm Pluton, which is itself 1.84 billion years old. So really they're about like 1.75 billion years old. They're pretty darn up there, these basement rocks. Now, they're the remains of an ancient mountain range, In this photo right here, you can see them very clearly. They're the gray-green ones in the layer right there. Now, after that, you have the 60-mile conglomerate. Don't confuse that with the 60-mile formation, which comes much later. So that is about 650 million years old. Now, that is one of the many ones within the Grand Canyon supergroup. So that's all together. Now, roughly about 1.255 to 740, 730 million years ago, I saw one account said 725, but that's one heck of a stretch. So the Grand Canyon supergroup was a very large group of rocks that is subdivided within the Chwar group and also the Unkar group, which were the elder group of them. Now, with the Unkar group, there's a bit of variation in people determining sort of really what is defining that group, sort of which groups of rock are within the Unkar itself. So I'm just going to go into some of the main ones that you'll find into it. So you'll see the Bass, the Cardenas basalt, and the Dox formation into that a lot. The younger group, you'll get about a half dozen plus subdivisions around three main formations themselves. So there's quite a bit of subdivision just within the Grand Canyon itself. Now, the Bass Formation is the oldest part of the Unkar group. It was once called the Bass Limestone, but that name is no longer accepted. It's still used in a lot of text, which, no disrespect to anybody, but it's actually really wrong because the rock is not only limestone. There's also argillite, breccia, conglomerate, dolomite, sandstone. Yes, it's sedimentary rock, but still, by far and away, not just limestone. Now, reddish in layer, the color is known for having some volcanic ash layers as well, and it also has the canyon's oldest fossils, stromatolites, which are these lovely things right there. Now, so this is a little bit looking into the various layers themselves. So the Dox formation is the red down at the bottom, and then you have the basalt, which basalt is typically very dark, obviously. So then the dark red above it, and then the striped is right up above. Now, just a little quick look-see. Now, which of these things in this picture doesn't belong? Anything kind of strike your fancy as to sticking out right here? Which of these things in this one not like the other? Anything standing out? Well, if you picked up on it, you're looking at what's called the Great Unconformity, which is right above those rocks, so to speak. It's a site of a gap, implied air quote. I actually did the little Dr. Evil air quote thing. I don't know why I'm doing that at the screen, but oh well. It's the site of a gap of upwards of 1.1 billion with a B years in parts of the Grand Canyon. That's right. A place as well studied as the Grand Canyon, we essentially have a billion years of missing time, theoretically, that it's not necessarily that we can't account for, it's just been eroded away. And that is what an unconformity is. So, really, what happened? We don't really know. An unconformity is a site of great missing geologic time. Missing, though, is a misnomer. It's not like somebody just had this in their pocket and it fell out through a hole or something here. The rocks of that missing time period are not really missing. They're just eroded. Something happened, uplifting, erosion, what have you. They were there, they're just gone now. The rocks above still formed above them, the rocks below were still below them. You just have a gap in between. Now, the rocks immediately above them are the ones from the Cambrian period, specifically called the Tonto group. They're about 507 to 597 million years ago. They began with the one that I mentioned earlier, the 60-mile formation, which is about breccia, sandstone, and siltstone. Now, here is a little bit of a look into things, and also, too, a close-up of the Tapete sandstone, which is a light to red brown conglomerate sandstone, becoming finer towards the top, and it overlies the Great Unconformity in many places. So, with a lot of the close ups that you see with the great unconformity, you'll kind of look like right above it, and you can see a pretty fine, like reddish brown sandstone. That's the Tapete sandstone. It's just honestly, people like to snap these photos because it's very photogenic. You get a nice, I mean, look at that picture. It's a very nice looking rock. I mean, come on, it's neat to look at. So, it makes good photos. Now, that's actually pretty interesting. So just take a little look at that. What do you think that is, really quick? And that right there, that is obviously a burrow. This specifically right here is the Bright Angel Shale. That right there is a statue in memoriam of Brighty, specifically Brighty of the Grand Canyon as he was known. Now, Brighty was a burrow that was famous, a wild burrow. There were actually, back in the time, there were many, many burrows. There's a lot fewer right now, sadly. That were running wild within the Grand Canyon itself. And Brighty was a famous one. He was kind of immortalized in a book that was written many generations ago, but still by a children's book author, and her last name was Henry, and so they have a statue to him. He was named after the rocks in there, Brighty after the Bright Angel Shale. Now, it's multicolored and fossil rich. Here's a little look into it. You can kind of see at the top, there's all different sorts of shells and things into it. And it's very known for interlaying, very tightly interlaying. If you kind of look into it into close ups and with geologic maps into a lot of the places, it almost looks like if you take your two hands and you put them together, like you tighten your fingers together like that, they're that close together. It associates a lot with this Mauve limestone, which is, it's not really just a limestone. It's like earlier, it's various sedimentary rocks, not just limestone. Now, that in of itself is followed by the Frenchman Mountain Dolostone, which is a formation that a lot of people kind of tend to either conveniently forget exists or they just kind of pretend does not really exist. It's not really necessarily a controversial thing in Grand Canyon geology, but the Frenchman Mountain Dolostone is just something that a lot of accounts tend to kind of leave off. But it's there, I swear. It's just not necessarily something that people talk about all the time. Now, but wait, the Ordovician, the Silurian, what happened to any of them? I mean, there are no such Ordovician or Silurian rocks found in the Grand Canyon. Why is that? I mean, why? So we found another unconformity in between all this. So what happened? What type of erosional event? Nobody knows, honestly. There was some sort of heavy erosion followed by the creation of a marine limestone about 385 million years ago. That specific marine limestone is called the Temple Butte Formation, and it's a very famous marine limestone, very, very beautiful to look at. You can see it kind of there in that little sort of like that, almost like that fold off to the left. So there's the Mauve limestone down there. And then one of the next formations that's coming up is the Redwall limestone is right above. Now, the Temple Butte is mainly seen in old river channels. So then after that, time obviously goes on. So what time period do we see next in the Grand Canyon with, well, what chapter comes up next? Turns out it is the Carboniferous. Now, here is a good look at one of the formations that we're examining here, and another look at some of the fossils into it. That was the Redwall limestone. Now, Redwall is kind of a misnomer. It's actually not normally very red. It's mostly naturally gray. It just easily stains from iron minerals. It's about 340 million years old, and it's a very, very, it's probably one of the more famously photographed, if not the most famous, because it just forms so many of the cliffs. I mean, you look at that, it's all these people here kayaking and boating around in the Colorado. So the Redwall limestone is arguably one of the more famous formations in the canyon, but still, absolutely beautiful all the same. And no, to answer an obvious question, I haven't been here. I do not like heights. Heights and I do not get along. My husband has tried to get me here many, many a time, but I would pee myself and faint. No, I do not like heights. No, thank you. And then after that, surprise, the Surprise Canyon Formation, which I just love that name. It's almost, you could very much tell. So the Surprise Canyon Formation is very, very rare. It's almost very hard to find. And that's one of those things that just makes me absolutely love just really science and geology in general, because you can tell that whoever named that was just, oh, here it is, surprise. And that's literally what they named it, just kind of as a really weird in joke. Just the simple fact that it's named after how it's kind of hard to pick up. So that is about 320 million years ago was when it was found. And then here is a further close up of the Supai group about 320 to 270 million years ago. It's separated from those other prior rocks from yet another unconformity. Now that is both marine and non-marine, probably from sea levels transgressing and regressing, so sea levels going backwards and forwards, they think. Now, here is there are two different formations coming up after that. There's the Hermit Formation, which is mostly sandstone, 280 million years ago. Now, there's also, oh, wait, yeah, 275 million years ago is the sandstone that's right there. And yes, you can see those are actually little itty bitty, teeny tiny fossil footprints in there. So left and following. Obviously, can't see footprints in there, far too far away, but still gorgeous scenery in this place. Now, the Toroweap Foundation, 273 million years ago, which is a shallow marine formation of rock. And then following that, we have this right here, which is the Kaibab limestone, another very famous one. Now, all of those formations, the preceding ones, just right after that, those, I believe there was those four, I believe, all those were in the Permian. Now, this one, the Moenkopi, which is the left one in the red, sort of like the red kind of almost like in the middle, was one of several from the Mesozoic. Little remains of it though due to erosion. So basically, mountain building and erosion starting about 75 million years ago is the main theorized cause for the western side of the canyon, kind of like what caused all of that to happen. Now, the question is, was our Grand Canyon once a series of mere mediocre ones? And that's a very, very kind of that's like one of the hotspot theories about the Grand Canyon right now was that at one time was it a series of much smaller canyons, and then uplift and erosion sometime during the Mesozoic sometimes somehow managed to connect things, or not really managed to connect things, but managed to get it enough of sort of open up the door, and then further erosion opened up these canyons enough to kind of get yourself a opening. Now, the Colorado River has entered the chat about 5 to 6 million years ago. That's the date at which a lot of people will say that the Grand Canyon was formed. That is, I will argue, pretty simplistic considering that, well, it didn't just magically spring into being. The rocks obviously had to be there, and the rocks were already there for over 1.75 billion years old. So, yeah, I would say roughly in terms of the age of the Grand Canyon, we're looking at 1.75 billion. But the erosion of the Colorado River about 5 to 6 million years ago. Now, it erodes about 0.402 millimeters per year currently, and its gradient is about 8 feet per mile. Now, a cooling climate brought about more water 2 to 3 million years ago, and an increase in erosion with levels reaching today's about 1.2 million years ago. So basically, once things got to the level about say say like right around, I don't want to say, well, a bit more further back before like the Pleistocene and what have you, once things started to really cool down, not to the level of the Ice Age, but few million years back further from that, then you got a lot more water. So that started to peak up the erosion, and that was what really caused a lot more of what we have today. Now, much of the erosional activity today is rockfall. You can kind of see it sort of, not really off center right there, but kind of at that spot. Now, the Grand Canyon, surprisingly enough, it actually had a rather tough spot to try to become a national park. If anybody's ever seen the Ken Burns special or trying to or in the national parks, I can very much recommend it myself. It's absolutely wonderful. It's a bit dry in places, but the Grand Canyon Park is wonderful. It became a national park on February 26, 1919, and contrary to myth, it was not signed in by Teddy Roosevelt. He was not president then. It was actually signed in by Woodrow Wilson, and it was first submitted as a park in amazingly 1882 by Benjamin Harrison. This thing was submitted and submitted and submitted so many times and defeated so many times to become a national park. And the question is why? Well, a lot of it came down to private interests. A lot of it during, say, even Teddy Roosevelt's time, there were a lot of people even grazing their cattle within the Grand Canyon, and people were fighting it so that they could keep grazing their cattle and trying to, say, mine and hold other private land interests within the canyon. And then these guys, say, muscling in and kind of strong arming certain local politicians. These things sadly happen, and these bills kept getting defeated over and over again. But thankfully, Woodrow Wilson was able to sign it in, and it has been a national park ever since for over 100 years now. It is, like we said earlier, just over 1.2 million acres. In 2023, it received 4.7 million visitors, and it was declared a UNESCO World Heritage Site, justfully so, in 1979. So, thank you very much, folks, for joining us today at this look into the grandest of all canyons. I would very much recommend that you go, just as long as you're not like me and you pass out pretty much as long as you're not standing above 6 inches tall. So, thank you very much for joining us, and have a lovely day now.